Good evening, everyone. I am Vikas Kumar Roja. Today, I will be taking the second session of studying about Heap and Stack. A review from the will also and we will also looking at scoping and structures. But before all that, I will give a brief review on this. It will be necessary for the
Because
yeah.
I think your audio is a bit low. Like turn up the mic or something.
So is it fine now?
I think yeah.
Audible? Hello. Is it more audible like this?
Yeah, it's better now.
So can I start now? So hello to all. Good evening. I am Vikas Kumar Roja. Today's session will be taken up by me. I will be talking mostly about stacks, heap, malloc, free, and quite a bit about scoping and structures. And stack and heap will be quite a bit of revision for you all, as it was done in the session one. But before that, I will do a quite review of pointers. So let me share my screen. So is my screen visible? Okay, so we all know to declare a pointer, we write the data type of the pointer with a star and write the name of the pointer, let's say PTR. And it's a good programming practice to initialize the pointer to null value. Let's say PTR equals null.
Vikas,
Yeah.
can you zoom the text a little bit?
What?
Can you zoom the text a little bit?
The text.
Yeah.
Okay. So is it fine?
Yeah, better now.
Okay, so this is how we define a pointer, and I always prefer to initialize the pointer to null value, so it doesn't point to random memory location. So let's define an integer variable n and define its value as 3. We all know that to get the address of the variable, we use ampersand. So ampersand n actually gives the address to the variable n. So we can assign that address to the pointer as ptr equals ampersand n. So now our pointer is having the address of value n of the variable n. So now our pointer is pointing to the variable n. So we can actually check this by couting the value of n. So we can first see out the address of the variable n. So I am running the program. So you can look, this is what the address of PTR is. And to derefer the value of the PTR, you will have to use a star backside of the PTR like this. And if we will run the code again, it will show us the value stored in that address. The current output is showing the address of the PTR. And if I will run the code again, yeah, it shows the value 3. Since it was pointing to the address of n and n contains the value 3, we are dereferring, since we are dereferring the pointer with a star, it's pointing to the value 3. So that's what a pointer is, and it is always better to initialize it with null value. And one more thing, do note that size of pointer is not depending on the size of the data type with which you are defining. It's always 4 bytes, like see out. Size of n star. So the size of function returns the size of a given data types in byte. So let's take what's the size of any variable declared in insta. It's sorry, I have to save the program and it's 4 bytes. Looking up to char star. We again look there, find that it's of size 4 bytes only. So size of the pointer do not depends on the data type of means int star doesn't means the size will be same as int, because when we see out the value of the char star, it was not 1 byte, rather it was 4 bytes. So it is something important, and I will use them in the slides. So let me start up with my slides now. Hopefully this much of review is enough for pointer. Any doubts? I think all is fine, no doubt. So I will proceed from here. So yeah. So we will be first talking about memory allocations and how do C++ programs allocate memory. And first of all, we should know that memory allocation is an important part for any program to run, because for a code to run, the computer has to first save the text of the code. Along with the text, it has to save the functions and the variable that has been used in the code to make the code run. So in C++, memory is allocated in either stack or heap. So let's have a deeper dive in them. So let's look at stack allocation. So stack allocation happens in continuous block of memory. If this is not much clear what is meant by continuous block, I will make clear in the next slide. So just for now, just remember it. And size or the memory space that has to be given to this stack is determined the compiler only, while the time it is compiling the program. And the stack contains all the variable and the function that is present in our program. And whenever a given function or a use of variable ends, that is the scope of the variable ends, the memory allocated for that function or the variable is deallocated. So since the memory allocated to the stack is not temporary, it's get deallocated as soon as the function of those variable ends or the function get out of the scope or this use of variable ends. So it's kind of temporary memory allocation. And since it is not a permanent memory allocation, is help in efficient memory management. It frees up the memory as soon as it go beyond the use. So towards the right side, you can see how a stack is generated. Generally, we have function in C++ we have, which is int main. Int main will have certain variables like int a or int b. Int main will itself call some other functions such as f1, a function 1, and a stack will be created for that function also, and which will store its variable. And function 1 may call some other function 2, and a stack will be created for that also, and it will store the value inside all the variables of in the function 2 inside it. And similarly, if there is more calls of function, it will go up like that. So in the memory and the stack is accessible as long as it is running, means the function, you can access the memory from the stack until and up to the time when the function is running, means the function hasn't written any value. And the size of this stack depends upon the OS that has been used. And if you try to allocate more memory than the maximum allowed memory storage in the stack, you will get an error such as stack overflow. So that's towards the right hand side, you can just get a glimpse of stack allocation. And let's look at a program which will help us to know how stacks are created. So here is a simple program to give the square of a number n. So first function that will run is int main function, which will have a variable n equals 2. And int main will call another function square of n. So another stack for square function will be created. As you can see here, initially there was a stack for int main function. And since it called another function square, stack is created for square function also. And it stores the variable of the square function such as x and c. And to define c, we call another function as known as the product function. So a stack will be created for product function also. So the product function takes input of two variables a and b and returns their product. So this is how the stack will be created initially. And after the product function ends, that is, it returns the product of the two value, the product function ends, it will be removed from the stack as its function has ends, and it will pop out from the stack. And so we will be left with only two memories in the stack, of one of int main and one of square function. So as the square function will return return its own value, the product of the variable itself, it will also end, and finally the command will go to the int main function, and it will see out the value of the square of the n, and int main also will come to a halt after returning 0. And that's how this stack will be formed and stack will be ended. So this is how formation takes place, and this is how the stack is freed also from the memory. Now, this is all about stacks. Before going to heap allocation, let us know something more about pointers. So till now, in the beginning, I gave a bit sort of review about pointers. This is a sort of review about pointer also, where I have allocated a variable n as value 2 and a pointer pointing to its address. Here are the output of the above puts, the value of the pointer and the value stored in the pointer. But you have seen that pointers store value. If I define a pointer of data type t star, it can only store a variable of size of data type t. In order to store more than the given size of it, in order to store more size, we can use another function known as the malloc function. So actually, the memory to which the pointer is pointing can be controlled by us. That is, the size of the memory to which the pointer is pointing can be controlled by us using the malloc function, which I will be talking about. So malloc function. So malloc function is used to allocate a certain size of memory to the given pointer. Till now, we were allocating the pointer only to store the single value of the given data type. Using malloc function, we can store value as much as we can, and the amount of memory that has to be allocated can be determined by during the runtime of the program only. Means when the program is running, we can give the program the value of the memory that has to be allocated, and the program will do so. So here is a program of how to use malloc function. As I have said here, I have declared a pointer ptr and then integer value n. So n actually represent the number of integer that has to be stored in the pointer. So user will first input the value of n that has been stored, and then I will malloc the pointer. This is the syntax of the malloc function. So ptr equals to bracket insta malloc n into size of int. So inside the malloc, we have to write the size of the data that we want to malloc, the size of the memory that we want to that we want our pointer to point. So size of return size of integer variable, that is 4 bytes, and n is the number of value that we want to input. So n into the size of a integer variable. And the thing is that the return value of malloc function is actually void star. So we actually have to typecast it. So by typecast, I mean to change the type. Since the malloc is returning the the data type returned by malloc is a void star, but ptr of the type int star, so you have to first malloc it. And the mallocing means to change the data type. So we have to write the data type to which it has to be changed, which is int star. So now our pointer points to a memory location which can store n number of integers. And how it store n number of integers will be made clear in the next slide. Yeah. So here is what happening. Assume n is 3, and this is the syntax of malloc. So we have malloc the pointer, and we have malloc it for 3 integers. So the pointer can store 3 integers. So size of the memory that will be malloc equals to 3 into size of int. As the size of int is 4 bytes, we will the pointer will be actually pointing to a memory location which will be of 12 bytes. 4 into 3 is 12. So here is diagrammatic explanation of how it will be pointing. So these are the 12 byte reserved where we will be storing our values in the memory alloc. And each of the square will be representing 1 bytes. Now we will see how to assign value to the pointers and how to extract value from the memory. So just a second. Yeah, so in the argument of the malloc function, we have to write the size in bytes that we want to allocate to the memory. We want pointer to point to a location of memory of this given size in byte. So this is the argument of the malloc. We have to actually input this size in bytes. So size of int actually returns the value of int data type. So n into size of int returns the total size that will be required to store n integers. Hopefully it cleared it out. Fine. So how do we allocate values to the memory and how do we extract the value? So since we have booked here 12 spaces in the memory, we can access first 4 spaces by using ptr plus 0. And we can derefer them to write the value inside them. Here we have write that ptr plus 0 star equals to 1. So the first 4 bytes will be storing the value 1. ptr plus 1 will refer to the next 4 bytes, and it will be storing value of 4. And ptr plus 2 will be referring to the next 4 byte, which as per our program will storing the value of 3. So this is how we can make pointer store values. One more thing, since it was of int type, the pointer was of int star type, we were taking 4 gaps. But if it was of some other data type such as char star. So since each variable of char star just take 1 byte of memory, after every 1 byte we will have a new variable. But in the case of int star, after every 4 bytes we will have a new variable value. Okay, just one more thing, just like in mathematics, a plus 0 is a. So instead of writing PTR plus 0, we can just write PTR. As in line 9, star PTR of 0 is same as star PTR. And in line 12, star PTR plus 0 is same as star PTR. So is it fine till now? I guess it's fine only. Yeah, okay. So we were getting value of PTR plus n through star. Means we used to derefer the value of PTR plus n through writing star PTR plus n. And we are getting the cout value of as 1, 4, and 3. There is an array way of inputting and outputting value through the malloc memory also. Actually, star PTR plus n is same as PTR square bracket n. So we can just modify the previous code as star PTR plus 0 as 1, star PTR plus 1 as 4. By writing this PTR square bracket 0 as 1, it will automatically assign the initial 4 bytes to 1. And star on PTR 1 equals to 4 will allocate next 4 bytes to 4, and PTR plus 2 will allocate another 4 bytes to 3. Similarly, we can see out the value of pointers at PTR 0, PTR 1, and PTR 2, as it was done previously. Instead of using star PTR plus 0, we can just write PTR square boxes 0. And so here is the general way in which we define an array and output a value from the array. So we actually define int or array of a certain data type, say int, and we define the number of values that has to be that will be put inside the array as 4. So the work of the number of value that has to be inputted inside the array is similar to what we are doing here in the value of n. And here is 3. It is storing 3 variables, 3 values. And for here array, the number of values stored is 4. So it will be storing 4 values. So you can see a connection between pointer and array. And there is the output of the above program. You can see here. Till here, I guess it's fine. Any doubt? Okay. So we have seen malloc function allocate memory in the system. But if we keep on using malloc function time and again, we may end up using all of the memory present in the system, and it may affect our system too. So we have to remove the memory that has been allocated by the malloc function. For that, there is another function called free. Free memory just deallocate all the memory that was allocated through the malloc function. The syntax is very easy in the given program toward the left side. You can see that it's the previous program only where we mallocated the PTR, the pointer, and couted the values. And after that, we have to just write free PTR, and it will be deallocate the memory that was allocated by the malloc function. So here we see the free deallocates the memory to which the PTR was pointing. And that's all about free. So now we will go to heap. Now, when we defined a pointer and when we malloced it, a stack would have been created. But interesting thing is that when the stack was created, the stack kept the value of the star PTR, but do not keep the memory. But do not keep the memory to which the pointer was pointing. So where those memories are allocated. So those memories are allocated through heap allocation. As we have seen, stack. As we've seen the malloc, the memory is assigned during the runtime. So memory in heap can also be assigned during the runtime, that is during the execution of the program. And as we have seen in stack, the memory allocation is through continuous blocks. But in heap allocation, it is not necessary that blocks will be continuous in heap. And that's the another difference from the stack. And in the heap allocation, the programmer has to handle the memory by himself. Instead, as the function ends or the scope of the variable ends, the memory allocated to the function or the variables was deleted. But for deleting the the variable allocated through heap allocation or the memory allocated through heap allocation, the program have to himself free the memory, just like we have used free function. Okay. So here is how heap can be diagrammatic way, making the heap more clear. So here we have a simple C++ program and there is a function called main. So first we will start from int main. We will define ns3 and we will define a pointer which we will initialize to null, and the pointer will equals to the function n. So ns3 function is taking argument as 3. So the value of n here will be 3. So we will define a pointer here p and which we will malloc. So int star p equals int star malloc n into size of int. Since n is 3, so we are mallocing space for three values of integer. And we are using some mathematical way to assigning those value, which is pi equals to 2i plus 1 whole square. The function returns the value of the pointer p, and the ptr takes the value of the pointer p, that is the address to the heap. Note here the pointer p was referring to the address that was malloc. So now as ptr has got that address, now ptr is pointing to the allocated memory. And also one interesting thing is that after the function ends, the pointer p get destroyed, but the memory that was allocated through malloc still remains and can be accessed in the int main functions also. As can be seen here, through the for loop, I am counting all the values of the pointer. You can look at the output that the memory allocated through malloc is still available because it was allocated in heap. We have to free the value to destroy the value that was allocated in the heap, or it will be remain there. So that's how this shows the stack formation. We first call the int main function, and it stores the variable and the pointer, and the int main function itself calls the function fun, and it also shows the pointer and the other variables, and both the pointer p and ptr are pointing to the same memory location, that is the memory allocated through the malloc function. So that's in heap allocation. If more than one times we have used malloc function, it is not necessary that memory that will be allocated through heap will be allocated through malloc will be stored just above it or just below it. It can be stored anywhere. That's why I said heap allocation is not a continuous allocation. So everything is fine. Any doubt? Okay, one more thing. There is a data structure in C++ called as heap. So this is not the data structure heap. It is different from that. It's a method of memory allocation. In heap, memory is allocated, which is permanent, rather than a stack, which is temporary. So what did we go in line 7? So line 7 is a for loop. Actually, just I am giving some values to the pointer, the memory to which the pointer is pointing. The for loop is just helping me to provide the value through some numerical way. I have just assigned that the pi will be 2i plus 1 square. So it's just giving the values to the allocated memories, nothing more than that. It is just initializing those values or giving some values to those pointing memories. Is it clear that what line 7 and line 8 does? Okay. So that's what I have to say for heap. Let's go to scoping. So scoping refers to the extent to which a given variable or given a variable is available in the code, or the extent with which it can be used in the program. So this thing will become more clear with some example that I will be taking now in a few minutes. So in C++, scoping is done through curly braces. And when you define a scope within a function, or a function itself is a scope actually. And if you define some other scope also that is within a function, then each scope has its own memory space in stack. And function which is defined within the scope, after the end of the scope, the variable which were defined inside the scope, or if sorry, if you have defined a scope and you have inside the scope you have defined some function or other variables, after the end of the scope, those functions and variable gets destroyed. And let's look at a program here. This is not a simple C++ program. There is the int main function, and there is a scope within the int main using the which I have defined using the curly braces. So inside, I have created a new scope, declared an integer variable I, and assigned I as 100. Now look, as this scope ends, the variable I get destroyed. So outside this scope, the I is no longer available. So when I try to run the code to see out the value of I, it gives me an error. The error is that I was not declared in the scope because I got deleted as this scope and it is not available to the see out value of I. That's why it's outputting an error. So let's look at 3 examples. First is in first example, there is a int main function in which I have defined a integer type variable I as 23, and I have defined another scope in which I redefine I as 100. So just look that inside the scope, no new variable I was created. So the same I value will be taken here. So this variable I is same as this I, since no new I was created. In the previous code, the variable was created inside the scope, but in this code, no new variable is created inside the scope. So the I is pointing to the newly defined integer I, and we are just redefining its value as 100. So when we are trying to see out the value of I with point marker A, we will get the value as a 100, which means the value of I presently is 100. So after the end of the scope also, when we try to see out the value of B, see out the value of I using a pointer B, we will get 100 only because the value of I was declared here only, and here it got modified. Now, a simple rule of thumb: always look for the latest definition of the variable. Whenever we are working with a variable, the variable, let's say in the first code, the I was actually pointing to the initial definition which was done in the int main. So in the next program, I have this quite similar program. Here I have defined an integer variable I, whose value is initialized to 23. In the scope, I have redefined I. So when I redefined I, within the scope, a new variable I has been created. This I is not same with that I. So within the value, the variable I declared within the scope has the value 100, but the I outside the scope has the value 23. So when I try to see out the value of see out the value of I with a marking A, I will get 100. But when the scope ends, the I that was defined inside the scope get destroyed. So now when I trying to output the value of I, it is actually pointing to the initially defined I inside the int main in the line 6, that is int I equals to 23. So when I try to see out the value of I using the marking B, I will get B 23. Now, as I said, always look for the latest definition of the variable. When I was trying to see out the value of I using the pointer A, I was actually pointing to its latest definition, which was here, int I equals to 100. Here, here the variable has been defined latestly for this variable. But for the second variable, for second times when we try to see out the value of I, this variable has got ended because the scope ends. So no, the value of the variable that was declared inside the scope has been destroyed. So now this I will point to the previous integer I, that which was 23, and so is the output value. So till here, is it fine? Okay. Let's look at the last program. Here again, integer I has been declared, which is initialized to 23. Now inside a scope, another integer I has been defined, which is whose value is 100. And do note this, the I which is this and I which is this are both different. So when we try to see out the value of a, see out the value of I using the marking a, we will get 100 because it is pointing the latest definition of I for this variable is this one. And now we will do I minus minus. Actually, I minus minus reduce the value of the given variable by 1. So the value of our I is now 99. So when we try to see out the value of I again with a marking A1, we will get 99. Now as the scope ends, this variable also get destroyed. It ends here. And so now when I again write I plus plus, which actually increment the value of I by 1, is the I here is pointing to the initial definition of I here. This I is no more here as the scope ends. So initially I was 23. By doing I plus plus, we actually increment the value of I by 1. So the value is now 24. So when we see out the value of I using the marking B, we will get value 24. So yeah. So now we will go to a few definition of global variable and local variable. So till here, is it fine? Okay, I will understand that is fine only. Yeah. So global variables are those variables which are accessible through all the function. Means those variable which can be used by all the functions are known as global variable. To declare a global variable, you have to declare the variable on top of each and every function. This point has to be taken care of. To define a global variable, you have to define the variable at the top of every function. Here you can see int I equals to 1 is a global variable. It has been defined at the top of every function. It is above in function also. It is above int main also. And that should be actually taken care about. It should be above every function. Okay. And local variable are the variable which are defined within the function or within a scope. As was in this example, I is a local variable. Here also I is a local variable. Here the I is a local variable which ends as the scope ends. Here also I is a local variable whose which gets destroyed after the scope ends. Now this variable ends after the scope ends. I have already explained. And to assess this variable, you have to be in the given scope only. This variable can only be assessed within the within the scope in which they were declared. So okay, so that's what about local variable. And here is a function. Here I is the global variable that is defined above every function. So in the int main, first we will increment I by 1. So initially our value of I was 1. Now I plus plus will make value of I as 2. So now we will see out value which will be returned by the fun by a marking fun which will be I plus 1. Since I is now 2, it will be returned 2 plus 1, which is 3. Now in the subscope, we will do I plus equals 4, which will actually increment the value of I by 4. So now as the value of I was 2 after incrementing it by 1, the value of after incrementing the value of I by 4, the value inside I will be 2 plus 4, that's 6. So that's why when we see out the value of I using the marking A, we'll get 6. And similarly, when the scope ends, if we see out the value of I is still 6, so we will again get 6. So that's all about global variable and local variable. And in the next page, it's a fun program, and you can scan the QR code to answer it. Just scan the QR code and answer it in yes or no. I will wait for some time. So I will wait for a minute and then we will proceed to the answer. Uh, as lots of people have responded by now, I will proceed towards the answer. So The answer is B, the code will not work. And it was actually a tricky question because here I have wrote that global variable are declared above every function.
Vikas, your screen isn't shared.
What?
Your screen isn't shared.
My screen isn't shared. Okay. Is it fine?
Yeah, works.
Okay, so the answer to this question is B. The output will be an error. The code will not compile. The error is I was not declared in the scope of the function. So the problem is that for a variable to become a global variable, it should be declared above each and every function. Just look, this code and this code is too similar. Just the thing is that here in I is in the top of the function in fun, but here it is below the function fun. So the thing is that the function can only assess those global variables which are defined above it. Since none of the variables such as I was defined above it, we get an error, which is I was not declared in this scope. So is it clear? Yeah, so now we proceed to a new topic, structures. So far we have used arrays and vectors to store value, but the problem with arrays and vectors is that they store value of the same data type. So if we define an array of integer data type, it will only store integer values. If we define it of character data types, it will only store character values. But what we want to store value of different data types. Consider a case where consider a case where a person who is a fruit seller want to store the value of the price of the fruit and the name of the fruit. He cannot use array or vector in that case for efficient working. In those conditions, structures comes to rescue. So this is how a structure is defined. You have to write struct struct, which shows the starting of defining of a structure, and then the name of the structure. Here I have defined the name of the structure as fruit, and the data type that will be and the variable that will be contained in the fruit. So fruit will store the name and the price. So the structure fruit will store the name of the fruit and the price of the fruit. So here you can see I have written a structure itself define a sort of data type, which include other data type. And you can define structure either inside main or outside main as per need. So here I have defined a structure fruit with a string with name, which is a string of which is of string data type, and price, which is of double data type. So, and just note one thing, you have to end structure with a colon. So this is how a structure fruit was defined, and you can define a structure variable by writing structures fruit f. Just like you write int a, where a is an integer variable, you can here define a structure variable of kind fruit by writing structure fruit f. To assess each and every variable that was inside the structure, we can use a dot function and write f dot name, and we can initialize name as banana, and we can assign the value in name as banana and the price as f dot price as 32. So I hope this is quite simple of how a structure is defined and how do we assign value in the structures. So, okay, I will proceed to the next slide. So here we have first defined the structure whose name is fruit, which contains the variable name of data type string and price of data type double. So and double data type actually store decimal values. And here we define a structure variable for fruit as f, and we store variables such as f dot name as banana and f dot price as 32. Now, here is an alternative way of defining the structure variables. We can define the same structure as structure fruit string name and double price of data type double name of data type string. And after that, we can write f1 and f2. This f1, f2 are the structure variables. And in the increment, we can write f1 dot name as banana price 32 and f2 dot name as apple and f2 dot price equals 50. So here you can see in this the second program towards the right, I have defined two structure variable f1 and f2 and put some values inside the name and the price. And when I see out the values, this is the output which is shown here. So we get fruit f1 dot to get the value inside the structure. We have to use the structure name and the variable that we want to assess. Here the structure we want to assess the structure f1. Then we have to the name in this structure f1. Then we have to write f1 dot name. So it will output banana. And if in order to assess the price, we have to see out f1 dot price. It will see out the value of the price that was stored in the structure. That was 32 since f1 dot price was made 32. Similarly, we can in this we can see out the value of the f2 also, such like f2 dot name and f2 dot price. f2 dot name will return apple and f2 dot price will return 50. So the declaring of a structure and how to assess the value and how to output the value is clear. Okay, so okay, no. So double can store more amount of value than float. So let's look at the structure. So here I have means in the previous program we have stored value for two fruits as which name of the structure being f1 and f2. But in a general shop you have a lot of fruits, so you are not going to define 30 or 100 or 60 variables. So here what we can do is we can define an array of structures. And defining an array of structures is very similar to defining a simple array. Like we define int arr square bracket the number of values that we want to store. Similarly, we can here we can define an array of structure by writing struct fruit f and number of structures that we want to make 4. The number of structure variable that we want to have in the array, that is 4. So and like we can assess the first structure variable by f0 and assign the value to the name of the name variable in the struct by using f dot name equals apple. Similarly, we can write f1 dot name equals banana and f2 dot name equals pineapple and f3 dot name equals to cherry. And similarly, we can assign the prices. So we can, and here we can actually see out the name and the price of the structure in the similar way by using fi dot name and fi dot prices. And this will be the output shown here. So that's how we can define a array of structure and input the value to the array of structure and get the value to the array of the structure. So that's all, and thank you. Yeah, you can use vector instead of array.
Hello, Vikas. Am I audible? Hello. Am I audible?
The voice is a bit low.
Okay, let me check.
Yeah, am I audible now?
Yeah, you're audible.
Yeah, I just need, I just want everyone to like stay in the meet for a while. So we are going to have a first mini project today. We'll be announcing it today. So I would like to present the mini project for a while.
Edgerton, your voice is a
please,
little bit low.
Is it better now?
Yeah.
Okay, great. So for all the attendees, the camp is going to have 2 mini projects and 1 final project. I'm going to show we are going to share the first mini project today. So just give me a minute, right? I will just share my screen. Is the image fully visible? I just want to check it again.
Yeah, it is.
Yeah, so our first mini project is going to be about creating a process scheduler. So it's going to use the concepts of what we learned. The first one is the concept of what a structure is, and the second one is pointers. So we'll be using both these concepts to create a data structure called a linked list. I'll briefly explain what a linked list is over here, but we have added resources in the so the project is going to be on HackerRank. You have to submit your code on HackerRank. We have given a lot of resources over there. Feel free to go through it. I'll just briefly explain what a linked list is over here. So a linked list is basically a data structure where each data point also has the reference to its previous and next member, which has three values: the ID of the process, what the next process is, and what the previous process is. So you're going to have to create a struct with these three values as its members. And the next process is basically a pointer to the next process. The previous process is a pointer to its previous process. You're going to implement three different methods. Basically, add process, which adds a process to the last node of the linked list. So each of these data points are called nodes. Each structure is called a node. So you add a process to the last node. Like another functionality which you have to code up is called fork, which takes two process IDs. In this case, yeah, it's going to be 2 and 99. So you're going to find out process 2 in the linked list. Processes are just a structure. It's just a struct with three data values, nothing complex over here. Another functionality you will have to code up is called delete process, which finds the given process. So here delete process 2 is basically what you're going to be doing. You find process 2 in the linked list and delete it, which gives you this sort of structure, this sort of linked list afterwards. So I'll just, if you have any doubts, please feel free to ask in the chat or on Slido. Everyone has to make this code. Yeah, everyone has to code it up individually and submit the code. We will share them. How many total process you have to create? So you don't have to create anything. You only have to code up the functionalities. We have test cases which will like create processes, delete processes, fork processes, and check if your code is actually correct. So yeah, you don't have to worry about creating processes. You only have to code up
Hn,
the functionality. Yes, tell me.
people are asking in Slido if the struct should be saved on heap or stack.
So the thing is, if you're trying to save the struct on stack, it's very likely going to go out of scope because this is in a loop, right? So if you create something in that scope, when it goes out of the scope, the struct gets deleted. So you can't really save it on the stack. You have to save it on the heap. You don't have an option. So like struct isn't something you can do. Anything else? Can you give a HackerRank tutorial? You have never used it. Won't we be working on Replit if we are going? No, we are using HackerRank right now. So I'll look into HackerRank tutorial. I'm not sure if it's required. It's mostly like intuitive. You go to the link and you code it up and submit it. You can copy the code. It's not like a HackerRank test. Like you can take your own time. Deadline of submission. As of now, we are planning on Monday, but if people ask for extension, we are free to provide it, and if people are uncomfortable with it. If we delete a process, the child process will also terminate. Aren't implementing? No. So we aren't implementing that way. So if you delete a process, only that process gets terminated.
HHN, people in Slido are basically asking you to explain fork again, how a process is forked.
Yeah, sure. Okay, so I add process basically adds a process to the last node. Fork process, as you can see, initially there were just 3 processes in the linked list: process 1, process 2, process 3. Fork, it's a function which takes 2 parameters. The 2 process IDs. The first process ID is the parent process sort of, which in this case is 2. The second process ID is the child process. In this case is 99. You're supposed to add a new process after the parent process, basically. So in this case, initially it was 1, 2, and 3. Now it's process 1, process 2. You add process 99. As you can see, 4, 2, 99. You add process 99 after process 2, and then comes process 3. You have to keep this in mind that process 3 isn't lost. It should be added after 99. What do you mean by a process? So in this case, process is basically a structure which has 3 parameters: its ID, the next process which is supposed to come after this, and the previous process. In case of the first process, previous process is going to be null value. In case of the last process, its next process is going to be null value. So basically, they're going to be null pointers. The previous process of the first process and the next process of the last process. Kind of confusing, I guess. It's like a doubly linked list. Yes, it's a doubly linked list. You can implement it with a singly linked list also. I mean, it's up to you. It's up to you however you want to implement it. We only are going to check the final result. We aren't going to force any sort of implementation. इसका project questions instructions मिलेगा ना? हाँ, we'll be sharing the HackerRank link, which will have this image and all those instructions. Is it okay if you write in C? You should be able to write the code in C too, but we prefer C++. Like you can compile C code in C++. It's basically concept of struct and pointers, which are there in both C and C++. After forking process 99, next process is 100 or 3. Process isn't like in an order 1, 2. It isn't 1, 2, 3. The process IDs can be anything. I have just written 1, 2, 3 because it was the process IDs aren't like sequential by any means. What is next process or ID of the last process? So after the last process, next process, the pointer is a null pointer. Where should we submit HackerRank? We will give the link. Don't have to worry about it. No projects in the last session. So it's only going to be 2 mini projects. This Friday, next Friday is another mini project, and project on the last session. I can share the image. I have posted the image in the group. It will also be in the HackerRank session. You don't have to worry about it. So the 3 operations. Yeah, you have to code up 3 functions. That's it. Add, delete, and fork. That's all. I have also given the function definition in the HackerRank lets me give a starter code where the function definitions are given. Let me just show it. Okay, I will share the link later. It might be hard to show right now. We'll share the link. You only have to write code in those 3 functions. You don't have to do like create your own functions or anything. It's mostly set in there. I'll be in the meet for 10 more minutes. If anyone has any questions, feel free to ask.
HJ,
Explanation
can
part.
we share the attendance right now?
Do you need to? Do you need me to stop for anything? Should I stop sharing?
No, I'll just put the link in the chat and I'll screen share the QR.
Yeah, fine.
Is the QR completely visible? Can you confirm?
QR is visible.
Guys, we also request you to use the rating system to tell us how good the session was and if there are some things that we can improve in it.
Yeah, session. All sessions will be recorded. Uh, it's fine. It's today. It's going to be common attendance for both the camps. So we are using the same sheet.
It's okay if you have filled it for competitive coding conclave. We'll take your attendance from there. Don't worry.
Yeah. Feel free
Yeah,
to
feel
leave.
free to leave if you have no doubts.
Yeah, recording will be shared. All the slides, recordings, everything is being uh, collected and we will share it with you. Don't have to worry about it at all. Uh, we are planning on Monday, but we are open to giving the extension if a lot of people haven't finished the project. Monday is the plan right now, but it depends. Like if a lot of people ask for extension, we will give it.
Guys, I'll clarify this one final time. If the form shows that it has been submitted already, then you probably attended competitive coding conclave before this. So we'll take your attendance from there. You don't need to worry about that.
Yeah. The submission link will be shared for the mini project.
Okay, guys, I'm hoping you all have filled the attendance, so I'll stop the poll as well.
Okay, then I'll end the meet.
Okay. Keep it on for 7 more minutes, right? Like we'll end at 8:10.
Okay,
Okay.
fine.